There we go. I think we're on here. I think we've done it. So once again, welcome back. Welcome everybody from the L1X community and from everywhere else around the world as well. Good morning, good afternoon, good night, good evening. I've got to come up with a few more good things because I'm starting to exhaust all the ups and downs of those. But we have a really awesome presentation and, of course, a classic Kevin Miro board prepared for this evening or this morning, wherever you are, about it's a deep dive into the consensus mechanism. And, of course, we've got the L1X founder, Kevin, with us, and also a very special guest, our research manager, Niraj. It's awesome to have you here. It's going to be, I suppose, fantastic, showing the depth of the team that L1X has got behind us as well in all aspects of things that we're building. And it's just going to be a fantastic show to show how everything kind of works in the background, as it has been this ongoing series. But I won't natter on too much, because otherwise we'll end up like we did in this morning's space with L1X meme coin launching about beard token and all sorts of stuff. So I'll pass it straight over before we get out of hand. Kevin, would you like to kick us off?
Yeah. Thanks for that. Good morning, good afternoon, good evening to wherever you are. Welcome to the second episode of L1X Tech Tour. Today we'll probably dive into L1X Consensus. But before I begin, maybe Dr. Neeraj, if you want to introduce yourself and give us a little bit, give the community a little bit of background about yourself.
Sure, Kevin. Thank you so much. Hello, everyone. My name is Neeraj Khairwal, and I have got an IT industry experience of more than 13 years in academic as well as of the industry as such. So I have been working on the blockchain technology since last more than 5 years, where I have been into research. I am happy and glad to share that we have also received Australian innovation patent on the blockchain interoperability patent that we had filed. Similarly, we are also looking for an Indian patent to get granted soon. So apart from that, we have many research papers published in the public domain as such. So that is about myself. Back to you, Kevin.
Yeah, thanks for that. And, Neeraj is a pretty humble person, just like me, Joe. She's a PhD in blockchain interoperability. And, having her on board kind of helped me out, because when I, drafted the version 1 of the white paper, we were at like 60 pages. And then Dr. Neeraj and Dr. Pony Clark, the head of blockchain at UWA, stepped in. And they are responsible for the version 2. They extended it from 60 pages to 120 pages. So it has been fun working with, Neeraj, because a lot of discussions, when you start in interoperability, it's hard to find people that can carry the discussions at the same level. And when I, started discussing with Neeraj, and it was a conversation where I was interviewing her and, for the job, and it was supposed to last for like 30 minutes. It lasted for 2 hours, because she had already gone through the white paper and was already suggesting what we could do. So that was great. Okay. Without any further delay, let's jump into the whiteboard and let's look at what we have today. Yeah.
Fantastic. Classic Kevin Miro board.
Yeah. I think it's 100% needed.
I guess I should start, right?
No, I can get started.
Okay.
Yeah. I'll hand it over to you once the consensus comes through. Yeah.
Okay, fine.
Oh, it's funny why it's not letting me. But anyways, let me share my entire screen. Okay. Perfect. All right. So can you guys see my screen, please?
Yes, sir.
Yes.
Awesome. Okay. Okay. So today's topic is basically around, our consensus mechanism. So we are going to go over the proof of X network architecture, the consensus mechanism itself, the network framework as well. So how the nodes are divided, the contracts, or, because we have different types of nodes, we have different level of activities that these nodes do. And what does the contracts look like? Even the transaction type, the block types. We are going to go through the transaction lifecycle. We're also going to look at the database drivers that we use. We'll have a look at the fee model. And maybe we'll touch a little bit upon the reward structure as well for the nodes. because we are drafting a wiki, so that everyone can look at it at the same place. So for those of you who are new over here and want to know what Layer 1X is, basically Layer 1X provides three different features. The first is it allows you to go multi-chain, so you can have your assets across different chains, and it lets you manage that as well. It also has a native Oracle system where your information that you want to bring onto the network, you don't have to use a third-party application to do that. And the third one is, it's built in a way to solve the blockchain quartet, including, the scalability, security, decentralization, and interoperability. And to do that, it has a feature shard strategy. So many blockchains have shard the database, but we shard according to the features that we offer. So yeah, these are the three key pointers that define Layer 1X. Let's jump into the proof of X network architecture. All right. So I understand a lot of you have already, gone through this, and I like to reiterate it so you get used to this architecture as well, because for those who will be hosting nodes, it's pretty important to understand this. So Layer 1X has two different types of nodes. And the reason we do that is because in the blockchain quartet, when you're trying to solve the problem of scalability, security, decentralization, and interoperability, if you think about it, I don't think blockchain scalability currently is a problem. And the reason I say that is there are a lot of blocks on a lot of Layer 1 chains which are empty, right? There are not a lot of transactions in them. Now, of course, you have Bitcoin and Ethereum that get clogged up. But again, until we don't create a strategy of moving assets, from one position to the other, you are not going to leverage the aspect of scalability anyways. That's like if you're trying to send emails, if emails were not, going to go from Yahoo to Gmail, why would you need, 10 million emails a second, right? You wouldn't need that much. So again, our focus right now is on interoperability and security. And at the same time, we will work on the decentralization and scalability aspect of it. So being able to securely exchange information is the priority. And in order to do that, we have two types of nodes. One is the event listener node, which is over here. And the second type of node is the full validator nodes. Now, the event listener nodes, as the name suggests, is an Oracle system that is the xtalk node, like we call it. And we have another AMA that we've already done on that. So on this AMA, focusing on the full validator node, the full validator node is again divided into three different parts, right? 3 to 4 different parts. The first one is making sure that the L1X transactions don't have a bottleneck, right? So the full validator node in the first instance focuses only on that. The second one is the type of contracts. So there are certain times where you need to transfer the native coin through the contracts, and this is where two types of clusters, they come together to function accordingly. And we also have the xtalk and EVM. So the xtalk specifically understands that if the event listener node is to go and execute a certain piece of software on the full validator node, it has to first interact with the xtalk node. Because what we have done is when you want to listen to a certain event from an external source, the xtalk node has a contract called as source chain registry. You will go and say that I want to listen to my address or my contract address X for information Y on place Z. That information is stored in the xtalk nodes. And that is why the event listener exactly sends this information back to the xtalk node to know, okay, once I receive this information, what else do I need to do? Now, many of the chains over there, I think it's Red Belly in Australia as well, where they have forked the EVM infrastructure, solely relying on EVM. But in the VM AMA that we will have, we will see the gaps that we find in EVM and how there can be a problem of scalability over there. But to increase the adoption, we have an L1X EVM instance running with us, meaning although you may go and deploy a contract that does not interact with L1X VM at all, you can just use the L1X EVM. But This is the line of separation where an L1X contract, an XTOC contract, an L1X EVM instance don't need to be, kind of tied up to each other. So you can have an XTOC contract talking to a L1X EVM, where you don't want to go and build a contract on L1X VM, so that it provides a way for developers to come and redeploy the same smart contracts they have, but still leveraging the interoperability aspect. So this allows them to like quickly spin up, a testnet environment, deploy their EVM contracts they have, and with a single XTOC contract, allow them to go multi-chain. So we have kept it in this way. It's pretty modular, and we do see that for the next 10 years, this kind of infrastructure will suffice. Now, just quickly touching upon the security points table, there are 5 areas that we have kind of recognized that we need to focus on from the security standpoint. So of course, the public-private key generation algorithm, we have the SEP256K1 that is even EVM compatible. We have the hashing data to the state. So how the data is hashed on from the transaction and the block level onto the state. We also have like a global snapshot checkpoint. And I'll come to that later on once we go to the supercluster. The other one is the node-to-node communication. So we have 2 types of networking architecture. So one is JSON RPC and one is gRPC. So gRPC uses something called as protobuf. What it means is it is easier, faster, and more secure to use gRPC when the nodes are trying to communicate with each other. But when a client, like, you send a transaction from a website to the node, that uses the JSON RPC. And of course, the block proposer verification. Neeraj will go into the POX consensus in depth, but we do have a randomization algorithm and a register where a node selected once will not be selected up to a certain point in time again for a certain epoch level. So this allows us, like, in terms of the consensus modularity, it allows us a great way of saying, if you don't want to use X, you can use Y and still achieve the same level of security, with us. Now, I understand that there will be a lot of developers looking at this video even right now and in the time to come. So don't freak out. I'm going to show you something, but that's mainly for the developers when we open source the code. So I've also created, I like to call it the hash wire, right? So I've also created a flowchart that shows each and every function, each and every calling that happens from one place to the other. And this flowchart is pretty complicated for everyday people, but this is only to be used when you want to go and analyze the whole consensus code. Like you want to deep dive into the code itself. This flowchart will help you to understand how the functions move from one place to the other. But anyways, we'll share this board across, so this will be there as well. Coming to the POX consensus phase, I'll let Neeraj go through this because she's the main person who has written this part of the paper, which has been approved by me, but it'll be best for her to go through this.
Sure. Thanks, Kevin. I'll just share my screen. Hello, everyone. So we'll start with the L1X consensus process. That is nothing but the POX consensus process. So to make it easier to understand, what we are going to do is we are just simply going to have a quick look how POX consensus is going to work. So to start with, what is the purpose of having a consensus mechanism? So the very basic requirement is to have agreement among all the participants, along with having decentralization, immutability, and security. So how do we ensure that our L1X blockchain network is decentralized apart from having the consensus? So for that purpose, we are going for POX consensus. So POX consensus is actually based on the X score. That is nothing but the X factor, you can say in simple terms, for each validator node. So how is this X score being calculated or determined for any node that is participating in the L1X blockchain network. So as you can see from this diagram, we have two things. First one is the stake score on the left hand side and kin score on the right hand side. So these are the two, you can say, major parameters which are contributing to the X score of the full validator node. So this stake score consists of stake balance, stake age, and locking period. So as we all know that a node is required to have a node NFT so that it can participate as a validator in the L1X blockchain network. But that is not the only factor which will contribute for the selection of the node as a block proposer. Apart from that, stake age and locking period would also get counted. So what does it mean? That apart from the stake, your commitment to the network would also be getting counted. So it's not purely based on the like amount that has been staked. Similarly, when it comes to kin score, now by the word kin, we mean like how connected uh, we are to this L1X blockchain network. So kin score, that is the term, that is the reason we have coined this term. So kin score will actually constitute of uptime. Uptime is nothing but like how much operational a node is. Next comes is participation history. So participation history is like it is more related to the your participation in the network. Say based on the time you were based on the time you were available in the network, how actively you participated in validating the blocks or validating the transactions or proposing the blocks when you got an opportunity. Next comes is response time. So as we know, response time is indirectly related to the throughput of the system. So when a node is having a quicker response time or say a lower response time, then we'll be able to handle the transactions more efficiently and in a like smaller block finalization time. So that is the reason response time is another factor that is getting counted. And the last one that we have is security measures. So this security measures is more related to like ensuring the identity and integrity of the participants so that we mitigate the financial risk as such. So these are the like metrics that are being considered to evaluate the uh, eligibility of the of a node to get selected as a what we say, to get selected as a block proposer. So you might ask like we have in all this seven parameters as such, right? 3 plus 4, 7 parameters as such. So would they all weigh equal? So the answer is no. We are actually providing flexibility to this. So first of all, why is that required? So the very basic reason is at the start, all the nodes would have got the node NFT, and price of that node NFT is same for all the nodes as such, right? At this stage. So next, what comes is stake age. So since all the nodes are will be joining the L1X network now, like since ours is a new blockchain network, so stake age also becomes not that significant factor. So which factor will be contributing more as of now? So that would be locking period, for how much time the node is willing to commit to the L1X network and want to actively participate in the network. So at this point, locking period should have more weightage as compared to stake balance and stake age. So I'll just move down. So that is the reason we have created this sheet for the weightages for each parameter or each metric as such. So say initial 6 months, stake balance and stake age is having comparatively less contribution for calculation of your stake score, and locking period is having more weightage. Over a period of time, this can be normalized. In the similar sense, in this initial stage, your response time will matter more as compared to your uptime as such, because initially definitely all nodes would be willing to be available most of the time as such. So that is the reason we have added these weightage factors, so that the PX consensus mechanism is flexible as per the network dynamics are changing, so it is flexible to adapt to that. So you might be wondering, okay, we have now calculated the, we have now have these metrics as well as their weightages. So how are we going to get this X score? So for this, what we are doing is we are actually using fuzzy logic mathematical model. So as you can see, these are just the mathematical formulas as such, where each metric is getting considered. So I won't go into the depth of this. This was just to give you a glance, the how the proposed PX consensus is actually supported through the fuzzy logic min-max multi-objective model. So this flowchart will give us a quick review as to how would a node get selected as a block proposer.
Yeah, just before
Yes,
you
Kevin.
carry on, just before you carry on, Neeraj, I just wanted to give you a bit of perspective on why the response time is so important to us, right? So you think about, let's take a situation, right? Let's say there are two different nodes, and both of them have started producing the blocks and are syncing with each other. Now, let's say both of them have reached the block height of 100, right? So 100A and 100B. If, let's say, the B node drops, right? Let's say there is a network problem, the computer crashes. Now, the node A reaches 110, 120. Let's say the node reaches 120. When the node B comes back to life, if you look at, let's say, near protocol, the way the syncing works is it will get the most updated block 120 and start syncing in a descending order, right? The problem is, if there is another block which will happen in a few seconds, the syncing stops, it gets again the block height and starts syncing it over there. So the ability of node B to sync with node A is in a way where node B has to be faster than node A, if you think about it. Now, this sometimes can result in an inefficient and lock condition. What we have done is we have reversed that process. So if the node B is out of sync, it doesn't start from block number 120, it starts from block number 101 and makes it way up. But at the same time, because it's based on the block hash, our algorithm allows us to have this node run into two different perspectives, which is, one is the sync perspective and the other is the active perspective, which is it syncs up to block 120 and starts taking in transactions for this 121, 122, 23, but then still keeps going in the ascending order to finish the sync process. So instead of like this lockup mechanism where you're going in descending order and you're again trying to keep up with the whole flow, this is what we have changed. And that's why in the initial stages to test how efficient this is, the response time weightage is the higher. Yeah, carry on.
Yeah, thanks, Kevin. Thanks for giving more detail about this significance of the response time, why we have added the more weightage to it. So now we'll move on to this basic flow chart, where we'll try to understand like on what basis or how a particular node is being selected as a is being getting evaluated to be eligible to become a block proposer. So we'll have a list of active nodes in the L1X network. So initially we'll be checking whether they have the minimum stake, that is nothing but the node NFT as of now that they need to have. If a node doesn't have that, then node will be getting discarded from the list of eligible nodes to become a block proposer. Okay. If it has a node NFT, then in that case, the stake score will be calculated. So we have just now been through the various metrics which are being contributing to the stake score. So as we all know now that these three metrics have they have weightage added to each one of them, so that this stake score is calculated accordingly. Similarly, kin score is also calculated based on these 4 metrics that we have seen. Again, we have the weightages attached to each of these metrics, and we calculate the kin score for the node. So based on this stake score and kin score, we get the X score of the node. Now, if you notice, again, stake score and kin score would have weightages added to each one of them, so that the like X score for a particular full node can be calculated based on the like network requirements as such. So once this X score has been calculated, a threshold would be there that minimum this much X score should be there, so that a node can participate or become eligible to be a block proposer. If that is not the case, say if some node doesn't have a good response time, then in that case, in this, or they have very low participation history. So in that case, if they have got the X score which is less than the threshold, they would get discarded. So once this condition is satisfied, where your X score is greater than the set threshold, then in that case, the node will get added in the list of eligible nodes as such. So once we have this list of eligible nodes, then a homomorphic encryption will be applied on the X scores. So what's the rationale behind applying this homomorphic encryption is that this X score will be then, you can say in simple terms, private or confidential as such. So this will ensure fairness in selection of the node as a block proposer. So once this homomorphic encryption is applied, on top of that, randomization algorithm will be applied, so that L1X blockchain network has a, you can say, true fairness in selecting the block proposer. So this is how a block proposer will be getting selected. So this is a simpler way, you can say, how PX consensus is going to work, where it is taking into consideration different factors and providing flexibility as well, along with fairness, to ensure decentralization in the L1X blockchain network. Kevin, would you like to add something?
No, I think that's good. That's good. Pretty clear to
Okay.
me.
So now let us go through like transaction life cycle and try to get an idea how it is going to get executed in the L1X blockchain network. So I'll just quickly move on to, yes.
Yeah, maybe Neeraj, before that, I can go through the network architecture so that it becomes more clear.
Sure,
What
sure.
do you think? Yeah.
Definitely, that would be better. I'll just stop sharing.
Yeah, perfect. Thanks. Okay. So the next one is, we are going to look at why we have created this cluster-based mechanism, which is why are certain nodes responsible to do certain things, right? And before I explain further on that, let's take an analogy. Let's say, you're going to, I'm pretty sure, Joe, I don't know if you go and buy groceries or you order it online, but let's say you go and buy groceries, yeah? And let's take a situation where the moment you enter the supermarket, there is no tags available where things are, right? And everything is dumped in front of you. And now you got a grocery list that probably your wife has given you, and you got to find these things. If everything is dumped in front of you, right, and you got to find these items from the grocery list, the time taken is going to be enormously high. Maybe you may be able to do it, but by the time you finish it, the next grocery list will come up, right? So you're never going back home. The other analogy is when layer ones tell us that they are sharding databases. Now, what does that even mean, right? So what we have done over here, I mean, what database shard means is you go back to the same supermarket, and now all the products are divided in a sequence, right? But they're still not tagged. So if you want to buy, a bottle of milk versus a bread, it's still not tagged. You still don't know where to go, right? This will reduce your time, but it still does not solve, make it faster. right? Now the third one, which is what layer 1x is doing, which is feature-based sharding. What I mean by that, you go to the grocery or the superstore, each and everything is tagged. So if you have your list, right, and you have it in a sequence, your list in a sequence is clubbed together based on which row you got to go to, so that you don't have to follow the sequence, but you club your products from a certain row, move on to the next one, right? And that's why the feature-based sharding helps us in a way to do transactions faster, right? That is the rationale behind it. Let me share my screen. Yeah.
Got me living a perpetual nightmare of doing groceries.
Yeah. I mean, we think about it, right? And sometimes like these things are, we take it for granted, but imagine if you reverse back the situation, what would happen, right? Okay. So the full validator node network framework, as I mentioned, we have 4 different types of clusters. A cluster is a group of nodes. So the difference between a cluster and a node is that multiple nodes together in a single category is a cluster, right? It's like a team if you talk about it. Now, the L1X token cluster, it allows for the token transfer, the native coin transfer, right? So if you think about it, maybe around 7.5 to 10% of the transactions happening on a network will only be the native coin transfers. So these nodes are responsible to handle those kind of transactions. Then you have the L1X contract cluster. So if you have the BPT tokens, for example, the balancer pool spits out, right? Which is giving you 1% reward a day. Anyways, but the L1X contract cluster, anything relating to L1X based token, or you just have an NFT, or you have a certain logic you want to execute, like a voting system, it could be a game, right? Those kind of contracts are done by the other set of clusters. The Xstock cluster only comes into effect when the event listener node comes in. So if the event listener node is coming in, it knows where to reach out, as we have seen previously. And at the end, we have the L1X EVM cluster, right? Now, imagine you could have a Bitcoin cluster in the future. You could have different private network clusters, right? So the ideology over here is that it's not limited to these number of clusters, but at the same time, as we'll see moving on, the ability to come to a decision or a consensus ties up all these clusters together. So our goal as a layer 1 is to provide interoperability and security. And that's how these cluster-based systems allow us to provide the interoperability, but at the same time, tying up the consensus mechanism provides a level of security attached to it. Now, just to give you a perspective here, and I like to give examples because you can kind of like relate back, right? The Ethereum 2.0 beacon chain, right? So it has a way to shard your database. So if you have 10,000 records, 1 to 1,000 records in one node, 2,000 to 3,000 and the other one. But how do these nodes keep a track on the most updated state? For example, if your record is on node 1 versus my record is on node 20, and we are trying to do a transaction, how does these two nodes know the most updated state, right? That is why the beacon chain acts as a checkpoint. Okay, so this is where we all are at. So this is a checkpoint. It's a node in itself. So beacon chain are beacon nodes where you have to host a beacon node to have a checkpoint. On the other hand, if you look at the Nightshade consensus that Near protocol provides, it follows a similar strategy, but the checkpoint is not a node. It's a register that each and every person maintains, right? And in our case, it leans towards the second strategy. So superclusters are not nodes in itself, but they are registers. And these registers hold the block headers that are available in the token cluster, contract, EVM, and Xstock cluster. And that's why if you go back to the mathematical algorithm, the networking performance and the response time is high because we still need these guys to be able to perform well. Right. So we have three different contract types. We have an L1X VM contract, L1X EVM contract, and X-Talk contract. And when Neeraj goes through the transaction lifecycle, you'll see, how these contracts come into place as well. Now, why not have a single contract versus have three different types of contracts? The problem is an EVM transaction versus an X-Talk transaction versus an L1X VM transaction will have different level of templating requirements, will have a different level of response time requirements. So when these nodes are configured and they need to sync with each other, these kind of contracts allow us to focus a node on that specific feature sets. So if you send a contract function to to a node, and it has to now understand what is this? Is it a VM, EVM, X-Talk? What is it? It has to understand where do I send this to. So we thought the best way to do it is from the start, not kind of fit it in somehow. So the contract types itself help us to create templates for developers to build faster. It also helps us create feature-focused node environments. Now, there is a little difference in how EVM contracts and L1X contracts work. In L1X VM, we have something like a contract instance. And what that means is, let's take an example of an ERC20 standard or L1X20 standard, right? If you look at an L1X20 contract or ERC20 contract, 75% of them will have the same templates. But the problem is they all go and keep deploying these contracts again and again, taking up network space, storage. What we have done is, for contracts that we know are going to take up a lot of space and the templates are going to be the same, we create something like a contract instance. The difference is you don't have to redeploy the whole thing again, right? When you open a Netflix account and you subscribe once for one user, and then you can add multiple users in there. You don't create another account for the second user, third user, fourth user, fifth user. So in the same way, we save up on storage spaces and make it more seamless for developers to create these templates and create instances of it, saving us time and saving us resources on the blockchain. Again, because there are different contract types, there are also 4 different transaction types that the consensus nodes understand. So the first one we understood is the contract deployment, right? So as I mentioned, there are 3 types of contracts. Actually 4 if you consider the state contracts as well, but that does not affect the third party developers. So let's say you have contract deploy. Now, once you deploy your contract, you have something like a contract initialization. What I mean by that is, when you deploy a contract, the available information in that contract is still 0. Like it still doesn't know something exists. Contract initialization allows you to get started. For example, when you create a Netflix account and you fill up the basic details of yourself, that is initializing. When you create an account, you set up your payment gateway and you say to Netflix, I am signing up with my email. But the basic details is like initializing your account. Yes, I have reached a stage where I can start using the services. State changing function calls are, if you want to update a contract, for example, I'm trying to send a token. I am trying to update details about an NFT, which is a dynamic NFT. Such type of state changing calls. Now, even the state changing calls are divided into 3 different types. We have the L1X VM. According to that, we have the L1X EVM, and then we have the X-Talk over here. So different types of transaction has different transaction structures, and the state changing function calls have to adhere to those transaction structures. And at the end, we have read-only call. I just want to read the balance. And my theory over here is storing data on the blockchain for the long run should be cheaper. Because if you think about it, when you go to Amazon, host a server and a database, and even if you do not use it, you are still going to pay a base fee every month. Versus on the blockchain, you only pay when you update the state. So if I just want to read information from the chain, that should itself be, in a way that it's cheaper. So until and unless we don't make storing information on the blockchain cheaper, the read-only mechanism to benefit that, it's going to be free to read for your entire life, that can't be activated. We also have, multiple different block types. So we have the transaction block, we have the contract block, we have an EVM block, we have an XTOC block, and we have the super block. Super block is the collection of the block headers of the first 4 different types of blocks. And the reason they are different is because the transaction style is different, the contract type is different. So it has a ripple effect. So there was a point in time where we had to make a decision. The faster way to develop this and launch this would have been one contract type, one transaction type, one block type. But we are not looking to make things faster. We are looking to solve problems here. So that's why even the blocks types are different, right? And at the end of the day, when a super block syncs and holds all this information, it has to be readable by different nodes. So even that compatibility issues have to be solved in this storage flow. I've added some code over here as to the process of how a block is stored. Any developer out there can take a look at this code here. Okay. Moving on to the transaction lifecycle, I think Neeraj will be the best person to go through this. That will cover up, a lot of these different things that we have already gone through.
Yeah. Thanks, Kevin. So now we'll go through the transaction life cycle, taking the example of a multi-chain balancer pool. So like it will be easy for all of us to understand how is this L1X transaction going to work in this scenario, and covering all different type of transactions, which includes XTOC transaction, L1X VM transaction, and L1X EVM transaction as well. Okay, so we are considering the scenario multi-chain balancer pool. So say if I'm a user and I want to deposit, say USDCs worth $100. Okay, so first of all, what I would be interested to know is like how much balancer pool tokens I'll be able to get and what would be the price impact. So I'll be able to get that through the pool composition that has been done, so which is readily available. So the user will have a clear idea that once the investment is made, how much impact would be there and how much returns they'll be able to get at the initial stage. So based on that, the user can deposit this USDC to the Ethereum liquidity contract that has been deployed on the Ethereum network by the L1X. So this will help the user to add liquidity onto the client chain contract as such. So once the USDCs have been deposited on the Ethereum liquidity contract, then there will be a Ethereum contract which will be actually emitting the event. In the sense, will be having a contract deployed by L1X on the Ethereum blockchain network, which will actually capture that a user has added the liquidity onto the liquidity contract, and this will be actually conveyed to the L1X blockchain network. How? So that would be through the emission of the event from the client chain, and we will be having the listener nodes at our end in the L1X blockchain network, who will be listening to the events that have been emitted by the client chains. So what is the role of these listener nodes? So listener nodes will actually initially, as we can notice, will store the events that are coming onto the network. Then they will actually verify the validity of the event that has been transmitted. Okay. Next, they will be actually scheduling these events, and if say any formatting is required for L1X network to understand the event that has been transmitted, that would be done by the listener nodes, and they'll be broadcasting the event to the entire L1X blockchain network. So once the event has been transmitted to the L1X blockchain network, then in that case, what it will result is nothing but a transaction as such, where L1X VM comes into picture. So here what will happen is, initially the details will be registered along with the UUID of the user. Apart from that, we'll have a L1X EVM contract where we have the liquidity collection register, so that the investment or the deposit that was made by the user is registered on the L1X blockchain network. So based on the type of the transaction that has been initiated, it will be executed by the balancer handler. So it can be to join the network, or join the balancer pool. It can be for the exit, it can be for the swap as such. So once this transaction type has been identified as such, then based on that, this cross contract cross VM call will be initiated to execute the balancer pool contract. So that is how now L1X EVM will come into picture. So this you can say calculations will be made, so that we know how many balancer pool tokens are to be issued to the user based on the deposits that have been made. So once that is done, uh, this balancer pool tokens would be issued to the user as such, and then uh, like this will be actually handled by the L1X EVM contract liquidity collection, because that is where it will be getting registered that for this much deposits, these many balancer pool tokens were issued, and then the calculation and distribution will be done based on the network dynamics as such. So this is how your L1X, your transaction in L1X blockchain network is actually flowing across L1X EVM, L1X VM, and our XTOC process as well. Since a different blockchain network is involved, say in our case, we were considering the scenario client chain being the Ethereum blockchain network as well. So this is how a transaction flow would be there conceptually as such. Kevin, would you like to add something to it?
No, I think it's good. It kind of allows us to understand the whole flow of the transaction types, and these are like different transaction types being fired up through a cross contract call one by one. So yeah, I think you explained well.
Sure.
Okay.
Thank you. So yes,
Yeah.
I guess Kevin, you can continue.
Yeah. Okay. Going further, one of the other important thing is the database. Now let's understand what is the importance of the database. When we say that the blockchain stores information, right? That's like saying I like eating tasty food, right? But what exact food do you like, right? So what exact food do you like is basically that term. If you use it in blockchain analogy, it's called database drivers, meaning how does your data get stored? Like what is the way your data is stored in there and it is retrieved, right? What is the strategy behind that? Now, continuing on the same analogy, if you went to the supermarket, a family of 3 versus a family of 7 versus a family of 15, I don't know if there is, versus a family of 25, right? They will all have different requirements when they go to the grocery store, right? So if you're buying, let's say, I don't know, a bottle of cold drinks, right? You're not going to buy one bottle if there's family of 10. You'll have to buy 10 of them. Now, how do you position this? Do you prioritize a family of 10 first versus a family of 2, right? Or a family of 3 versus a family of 20? This is a question where, there is no definite answer to this, right? And if we are not providing a way where businesses can leverage this aspect, then whatever we have built, it's going to slow down when the database driver comes into picture. So I'll just share my screen and explain what we have done. Yeah. So, and I think these kind of conversations help us understand how much work has gone into the technology, right? If you look at, let's say, Polygon, right? Polygon is using RocksDB. I think majority of them use RocksDB. Now, the requirements of storing information on the blockchain is changing, right? And to understand what these different database drivers provide, let's go through them one by one. If you have a list like a dictionary saying that wallet address, balance, wallet address, NFT associated. If you have this dictionary, that is where RocksDB does very well. It's great, right? It's fast because it's built on this key pair relationship. Cassandra, if on the other hand, allows you to decentralize your database in a way where you have sharding strategies. So for example, let's say I want to go and create, let's say the government says, okay, let's build on L1X. And now the government says, okay, there are various departments, like there is health department, there is the taxation office, and all this information about this one single person has to be stored. So how do we store this? That is where Cassandra can help, saying that one person, ATO records over there, one person, health records over here, right? So Cassandra helps you to divide this information into various types, like what type of information you have. Because you can have patient name, health record, all these types of different column-based information there. Postgres is great where you want atomicity, saying that if I want to do this, but if something fails in between, roll back the whole thing. Now, if you're doing a swap, and let's say the user has done a swap on Ethereum and wants to receive it on the Binance chain, but the Binance chain contract returned an error, transaction dropped. That level of reversing back the information, right? Postgres has something called as a diesel ORM that is natively allowing us to roll back a certain transaction. So which one have we implemented? All three. So the ability of our nodes right now, we are using Postgres and RocksDB. So in the coming time, when businesses say that I want to use Cassandra because they are using Cassandra natively right now, they are using Postgres, they are using RocksDB, 95% of the business use cases are covered up. So you could come on the blockchain while sharing your data, but still keeping it centralized for you if you don't want to decentralize your information. And you don't have to change your database drivers just because we don't support it. And these database drivers are pretty agnostic, meaning that if there are two nodes running on two different database drivers, it doesn't matter because the consensus layer allows us to unify them and store it into a similar order or a similar state. So in this way, even if businesses are using different types of databases, they can go through the same level of consensus or not. And if someone wants to fetch this information, they can fetch it with a single API. So for developers, it wouldn't really matter how you fetch this information from the blockchain and how you store it into the blockchain. The contract types that you define, they leverage these type of database natively. So if you say you're going for a contract with a lot of information about a patient, it automatically understands and stores it in a Cassandra database. If it's a register, it stores it in a RocksDB. If it's you require atomicity, where you have got two different type of, so the destination has executed, the event listener again listens and says, okay, even on destination it's done. Now you need to update the state or reverse back. That time Postgres comes in. So our swap right now, they're using, on the version 2 with the balancer pool, they're using Postgres. So this kind of infrastructure allows us the modularity even up to the database driver level. And it's very important because We are trying to service the Web3 space for the next 10, 20, 30, 40 years, right? And these kind of things, like if you build it later on, you got to rejig the whole thing. And that's why it's prepared to take on any kind of multi-chain project we get, right? It's not trying to fit it in somehow. How do you build this on Web3? It directly makes sense. Now, going at the fee structure, right? So this is the fee structure in terms of the blockchain in itself. The more important thing to understand over here is we have unified the fee structure regardless of the contract types. So if you're doing an L1X VM, Xtalk, or EVM, you pay a single fee, right? So in this way, if you're transferring, deploying a contract, initializing a contract, creating some kind of a staking pool, or staking or unstaking, it is considered as a single transaction. After that, we verify the signature and the transaction, right? It takes the processing time. Now, this is where the fee limit is mentioned. Like you can query the chain and say, okay, what is the fee I require for this? And at this point in time, your fee limit is checked. Do you even have that much? If you do not have, the transaction will drop. It will not even go ahead. If you have it, it will charge that fee from your account. So once this fee is charged from your account, it depends, again, what are you trying to do? But let's say you go ahead and initialize a contract, right? And now you need to know how much fee is being used. Like how much did I exactly end up paying? At that point in time, when a certain contract is getting executed, we have different ways of calculating these fees, right? So if you're doing a cross contract call, your fee is taken out of your account. If you are trying to store it into the resources, the fee is taken into the account. If you're trying to write into a contract state, the fee is taken into the account. So each and every cross contract call, the fee is reduced out. And we have the EVM gasometer integrated, but the fees that we have for EVM, I think the last time I did was like 0.000 or 402 L1X. That's like 2 cents. I mean, 100 of a cent or something like that, right? For an EVM based transaction. So this allows the developer to not worry about the fee structure. So if it's an Xtalk contract, if it's a VM contract, because how do you pay for your Oracle services, like the information coming in, right? All that fees is taken up at one single source. So you don't have to, you can create an application in such a way that you have like event listener coming in, you have VM contract executed, EVM contract executed, and one fee for that's all the transaction clubbed together. So it provides us a lot of flexibility in calculating these fees as well. Before we go to the nodes reward, right? I just want to mention that the node rewards is still, we are still making sure that the rewards make sense, but I'm going to show what the rewards look like, right? In an Excel sheet. We have a front end being built where you will be able to calculate by yourself as well, if it makes sense for you, right? Let me share my screen. Okay. Is my screen visible?
Yep. Good to go.
All right, perfect. Now we are still working on it, but today we are going to go through the fee structure or the reward structure of full validator nodes, right? So what we are going to do is every month, we are going to allow a certain number of node NFTs to be activated, right? Now, this can increase, but I don't think it's going to decrease because we need those number of nodes. Initially, for the month of April, we want to target 80 nodes, 80 full validator nodes. So the moment you get your Xperts and Node NFT program out by the end of next week, you can go in and you can start registering that, okay, I'm going to host a node. So maybe there are like 800 full validator nodes, but only 30% decide to host, 40% decide to host, right? So considering that we have 80 nodes in this month, the block rewards for that month are going to be 3.33%, right? And that's like a 40% APR. That's huge with the coins trading. Now, if you think there are 80 nodes, we have reduced the number of L1X coins required to host a full validator nodes from 50,000 to 25,000. So made it half, right? And if you look at the total number of coins staked through the node NFT, that would be around 2 million coins with 80 nodes. The rewards that we get on that 2 million coins with 3.33% is around 66,000, right? Now, if all the nodes are taken up, then that single node in that point in that month is going to get around 833 L1X coins as rewards. But let's say, not a lot of nodes are taken up. Not a lot of nodes are hosted. If I reduce this down to, let's say, 50, the rewards are still going to be higher because there are set number of rewards allocated for that block. So the faster you host, the better it is for you to get these rewards. Now, the other angle to this is the number of coins that people are going to stake into the nodes, right? And what we have done over here is we have taken a simple probability. So let's say there is a probability of 60% of the people go and host into the nodes, right? It's always higher. At that point in time, in this month, there will be 10 million coins in circulation. 60% of the people wanting to host, stake into the nodes, that's 6 million coins. Even they will be eligible for 3.33%. So that gets the number to 200,000. Now, each and every person holding a node NFT gets the right to decide what the validator commission is going to be. So when you open up and say that I'm going to allow other people to stake with us or with my node, you can set the percentage you want as to what your commission is going to be out of it. So if on a blanket basis, the commission is 20%, right? And 200,000 coins are given to the people, out of that 20% is 40,000. This 40,000 divided by 50 people results into 800 L1X coins per node per month as commissions from the people. Now, that takes the total to 1,633. That's like around at 50 cents, that would be, I think, $800, $900 a node. And if you compare it with the other ones, Ethereum, Polkadot, I think the other ones are around 7%, 6%, 12%, 11%, somewhere there, right? Now, the hosting cost and the hardware requirements you're going to have, we have done an analysis and it should not exceed $100 a month. If it exceeds $100 a month, there is something wrong, right? So even with your expense going down to $100 a month with your node hosting cost, you're still going to net out. So for the full validator nodes, the number of L1X coins have been reduced from 50,000 to 25,000. For event listener node, it has been reduced from 10,000 to 5,000, right? And I kind of think that with the ability of, the coins reduced down, the number of nodes will increase. So thanks to one of the community member who recommended this, and it put me into thinking, like the goal is more number of nodes here. Like, what are we doing? So it's great. Now, the calculator that you're going to get is going to look something like this, right? So you'll don't worry about the 500,000 coins, but you're going to get this calculator here where you'll be able to go in and punch in how many nodes you want, the expected L1X price, the probability of L1X staked in circulation, your validator commission. Hosting fees are $100, but you'll be able to calculate your rewards based on that, and understand that, okay, if the coin price were to reduce, am I still going to make some money or not? Or if it's going to increase, will I still make money or not? Right? So if you look at this and you go, if the value of L1X coin increases, which it will, you're at a party. But even if it reduces, you're still going to make money. Now, let's say it increases, I don't know, let's say based on the average things that have happened in the past, let's say it goes down to like $7 with what we currently have going on, and only 20% people decide to stake, right? You're still going to net out quite a bit of money based on the price of the coin. So this makes the node NFT very lucrative, because there are only that many NFTs in the whole year, right? But the demand of them is still going to be there. So we will create this into the calculator, and you'll also be able to opt in, whether saying that, okay, do you want to accept coins from the other people? And based on that, your node health score will be given out. So as Neeraj went through it, your validated node score will be taken in consideration. And in the portal, everyday people who have L1X coins, let's say 500,000, whatever it is, who don't want a node or who can't get a node NFT, they can come and stake it with you directly. So you'll have an option to accept it or not from the others.
Little bit of sneaky node alpha there.
Yeah, it's pretty lucrative, because if you go to like stakingrewards.com and you look at the pricing, right? I was playing around with it. I went through Celo blockchain. I went through like many other types of chains. If the price of the coin drops by 15%, this is what I've seen on an average, you make a loss if you factor in the hardware cost, right? So we are trying to make the node hosting lucrative by all the node hosting providers who are everywhere else, right, to come and host with us, so that the network is more secure. Yeah.
Just
I think
before we move on, just from PK, he wanted to know, is that $100 for a third party to host? And if not, can we get a third party to host?
Yeah. So what's going to happen over here is you can host a node in two different ways. One is you can use your laptop and host a node, right? And the other way is you use a cloud provider. So if you use a cloud provider like Amazon, we'll have detailed instructions for that, and you'll be able to host it with clicks. That's what we want to do. And that's $100 there. On your laptop, I mean, I've got a M3 Max, it's more powerful than the service. So I could host a node up here, and we have tested it. Node hosted on developer's laptop, not a cloud provider, and it still works.
Fantastic.
Yeah, there's one more thing. So with the event listener nodes, what we are aiming to do there is so the event listener nodes are the Xtalk nodes that have to secure the multi-chain environment. And we are going to accept three types of assets on the event listener nodes to be able to stake. The first one is L1X coins. So you can stake with L1X coins. The second one is native coins of other chains like Ethereum, Avalanche, Polygon, BSC. So you can go and start staking those amounts in the nodes directly to earn a reward. And these tokens will be used for cross-chain transfers. So it's securing the node, and it is going to be used for cross-chain transfers at the same time. And the third one is taking the LP tokens from your balancer pool, or even from a single staking pool, and going and depositing in your event listener node. So if you deposited, in the USDC, USDT, or whatever L1X USDC pool, balancer pool, those LP tokens will be used to go and deposit on the event listener node, and you'll be earning a bonus rewards from there as well. But there are only that many people who can host the event listener node. Now there are like 800 event listener nodes that will start accepting native coins, L1X coins, and the receipt token to secure that node infrastructure. Right. And yeah, I think it's important because you need liquidity. So we had to find an innovative way that provides liquidity and secures the network at the same time. Yeah. Any questions?
A few from the community. I think you just answered that one. Can we use the LBP for the node? That's a short answer, yes. Access to the spreadsheet. Will we provide that?
Yeah, I think yeah, I would say wait for the calculator itself, right? The reason I don't want to provide the spreadsheet is because if this spreadsheet spreads across and we don't adhere to those numbers, then we'll be liable for it. The numbers are going to be close or maybe better, right? But wait until next week. It's just a matter of few days.
Perfect. I'll just scroll on down as we go. Will the emission for the node decrease over time? It seems, based on the Excel tab, it seems to be increasing, or is DD getting something wrong?
Yeah, I think if you're thinking about this, right, okay, two angles to this. The emissions on the nodes, meaning the rewards that we are going to offer to the nodes over a 12-month period, right? Up to the 12-month period, the bonuses are lucrative because this is the adoption phase. We want people to come in and secure the network, more transactions to come in so that the network is secure. But after 12 months, it may drop. I don't know how much it's going to drop, but we at least expect that the fees that the network is going to earn is going to be, in terms of the quality of fees, it's going to be much higher than the other protocols because you're trying to act as like the Google over here, right? So like a plug and play solution for multi-chain ability. So you'll be making a transaction fee every time this transaction happens. So we kind of think that it should be in a place where certain part of the fees are paid for itself.
Excellent. And this question around hosting node, and I'll just confirm this. Obviously, you need the node NFT to be able to host a node. And that's first in best dress on the X perks, basically, to receive that node. So the question being as well, I think once you have that NFT for a node, that node is then reserved for you, correct?
So as I mentioned previously, the guys who opted in for the event listener nodes, they are going to get that. And the ones who opted for the full wallet validator nodes, they're going to get that. So that place of theirs is not taken away, right? And the sequence is going to be, if there are 80 full validator nodes, who has opted in first? So it's according to the time series. So if you had started first and you went in, even you were not waiting for other people and you went in, I want to reward the people, or the protocol wants to reward the people who came in first and believed in it. So first in, best dressed. Yeah.
Yep. Makes sense. Let's see who. So is the liquidity that LBP event provided enough, or will we need more?
Look, the reason we extended the liquidity phase is because I think we had 30% completed, 35% completed, and I get it. People are waiting for the TGE. Right now, based on those 4 tokens, if the liquidity is let's say $600,000 in there, $700,000 in there, we can multiply the trading volume of that by at least a factor of 10. So initially for us right now, it's good. But the idea is that when the node sales happen, we want to take that amount and put it in the liquidity.
Excellent. Nice to see new faces and who's working in the background. Could we go more in depth what Norman Lips does? Couldn't find anything about him on LinkedIn.
Yeah, of course. So when I started L1X, I had this crazy idea, and Norman Lip at that time, he's always been a constant supporter of whatever I do. And at that point in time, he saw that, this like he believes in me more than the technology. And without a single piece of paper, because I couldn't even put it into paper what I had in mind, right? This is like in very early days. He invested money to get this started, and he has been a passive investor. But without him, I wouldn't even be able to start this up. Like, I had the money, but I think I needed someone else to push that angle as well, so that we get introduced to more people to invest the money. And he was the person to start the whole investment thing into L1X.
He's the OG.
Yeah, he's a great guy. He's the one responsible to support me along the journey.
Awesome. And I see Sleazy's got some classic questions because he wants to update his Sleazy timestamps. Last I heard, mobile validation will come after TGE. How much later? And will Wallet SDK be available for mobile before that? Will it include simple API calls?
Yeah. So the super cluster right now is a registry, as I mentioned. Right now, it's hosted on the nodes, but in the coming time, even the mobile devices will be able to host these super or block headers into them. So I would say our goal right now is to stabilize like the network in a way that nodes can go up and running. There are no syncing issues, block level issues. Once that passes through, probably let's say give it a few more weeks, and then the mobile devices will start, because the mobile wallet SDK is ready for iOS and Android. But it's like the tech is at a place where it's much more ready than the adoption. You see what I'm saying? So I have to slow down the tech a little bit and let the adoption flow, so that we go hand in hand. It's not too much for the market to consume.
Makes sense. One more from Sleazy. Kevin, you mentioned before that there are some optimizations for BTC transactions possible. Is that like a roll up, and can we compete with the Lightning Network?
Optimizations for the BTC transactions. Yeah. So at this point in time, this month, we are planning to integrate, when I say integrate, meaning like, allow the feature of Solana. In the next month, we do want BTC. But again, I think that the introduction of BTC, we will finish the technology. But what at the background, what we are also working on is we are speaking to someone who is a leader in lending and borrowing. So how does a multi-chain lending and borrowing protocol look like? Like lend on one and borrow on the other. And then the Bitcoin can be held as a collateral, right? So we can integrate Bitcoin into the swaps, but it would be great to have the showcase of Bitcoin as a feature rather than just show that it works. So that's the only difference there. But if that does not go through, then we will definitely have Bitcoin as in the swapping feature, and it will be faster. Because I mean, if you're thinking about utilizing Bitcoin as a cluster, then you can store your Bitcoin with us, us meaning the smart contracts, and then use the Bitcoin to trade, which is minted on L1X, and you can always go back and forth as you wanted.
Excellent. And one from DD, could you go more in depth how bullish WASM to eBPF is and what exactly it does for the average user?
Okay, I was going to have a VM-based AMA, but as this has come up, our head of VM is the ex-head of Samsung research for Knox security. So he's a pretty out there guy, and this idea of a dual compilation, like why are we compiling the code twice, he didn't get it. Like, what is the purpose of this, right? But as I see it, when you compile your code into WebAssembly, which is WASM, WebAssembly can be executed on the browser, right? And my vision over here is that I think blockchain applications and its adoption should be also browser based, meaning if I needed to execute a smart contract into a WebAssembly format, can I execute it on a browser directly? And that's a crazy idea, because nothing like that exists until now, because you're thinking smart contract should be executed on the node. Why is it getting executed on the browser? And the reason I say that is, when the zero knowledge proof that allows your browser to connect to your node allows this interaction between both of them, the load from the node can be taken away, but the security of the node can still be maintained on the browser. Because right now blockchains are only as secure as what you send to them. But what about how you are generating the data, first of all, before sending it to the chain? So that angle of how you are generating that data is where WebAssembly code can be executed. But the eBPF, on the other hand, will make it faster for the nodes to execute. Like, they are quick in execution, right? It's a register-based system. Because if you look at your Android device, up to a certain version, it was slow because it's stack-based. That is, your WASM is stack-based. After a certain version, it went faster because it was register-based, right? Now, if you can create this environment where even the interaction of the node and the browser, they interact with each other, you have a dedicated ID on your browser and the node talking to each other. Like, banking applications are so secure. I mean, it's only as secure as someone reaching out, right? But anyways, that would really help to take that adoption at the next level. So the user, if his browser is hacked or something like that happens, then it does not necessarily affect the chain. That's what I mean. So browser-based security for the user. So it's more on the security level, and things will be faster, right? So you don't have to send to the node, wait for its execution, come back. You can execute it here and send to the node with a proof.
Excellent. Yeah, I think that can be a whole nother, like you said, a whole nother AMA, really.
We will be doing an AMA on the VM exclusively, because that's my area. Like, that's where yeah.
Fantastic. Imagine the Kevin boards. There'll be Kevin boards everywhere. Will the adjusted emissions for nodes, will it change the tokenomics / emissions?
No, I don't think so. I think it's the same tokenomics model, because it's based on the same circulating supply that we had.
Excellent. I think that is mostly questions, unless anybody can sneak a couple in the last little bit. Yeah, so that's most community questions there. Anything, I think, to cap us off from either yourself, Kevin, or from you, Dr. Niraj, anything you want to close out on?
Maybe Neeraj, if you want to go first and say anything.
I guess from this AMA, the concept of PX consensus will be very clear to the participants and the community as such. So they will have a better idea how we are ensuring decentralization as well as fairness in this process of selection for the block proposal.
Yep.
Yes.
Yep. Okay. No, thanks for that. I just wanted to address one thing over here, which is the adoption thing, right? Like, it keeps me awake at times, because I am firing up on borrowed cylinders. Like, I am doing everything I can in my capacity to push this forward, everything, right? And one thing that I have a lot of belief in now is the multi-chain asset issuance and management strategy, which is, the narrative over there is, take your token multi-chain. That's it. Because previously, what mistake I think I made was making it too complex for the applications to understand what they can build, right? So now I feel that looking at various documentation, like today I was listening to the Avalanche walk messaging, they call it teleport. It's no different than the Polkadot's XEM, like inter-chain transfer. And I was like, that is so complicated. And it got me like, okay, I get it, right? And what we are doing right now is, we are creating a funnel where this single feature is so powerful, because all these projects that we are building, they're all using this feature. We are creating a funnel. Chief is preparing a end-to-end scope doc on that, where we'll be reaching out to all, like, if there are 10,000 projects, we reach out to 10,000 projects with these features. Like, because I feel at least 20%, 30% of the projects need this, So take that one feature. There will be 2-page developer docs created on that, on how to use it, development videos on that, and just go hardcore into that feature. So once we start getting these applications building with us with that specific feature, which is so powerful in itself, it's like integrating Chainlink, bridges, having multiple networks. It's so powerful, right? And you can't even do that anywhere else. That's why we have not seen that yet. So that's where we are focusing on. And I just want to tell the community that I understand that the adoption that we are having may not be at par with what Polkadot is, maybe what Solana is. But also at the same time, I want to mention over here that this is that moment of getting in, right? This is like, the phase where you're going to create value in the protocol. And having those kind of features and that scale, where I am not afraid of getting on an AMA with any of these layer 1 founders and going head to head and discussing on any of the blockchain components. I am open to that, right? Anyone in Web3. But having these features and pushing them at the applications, we have the research on terms of the use cases. I think that's going to drive the adoption, right? And we are going to pick that one and we are going to go hard with it. So the adoption will happen. The value will increase, and the technology is there as we have seen it.
Absolutely, I think that's it. Everybody, you're at the party where all the food's out, but nobody's got here yet. It's almost the best time to be here.
Yeah.
One last question from DD. Runway time for nodes is still 5 years, correct?
Look, I mean, we want the 800 nodes by 12 months, but then again, that's a very far-fetched perspective. Like, I want to focus right now because we have built the tech for the future, but let's focus at this stage to get in the nodes. Like, let's reach 80 first, right? Then we'll talk about the other ones.
Fair. And that's I think that's an excellent place to close out on. It's been a very, very in-depth overview, I suppose you would say, of the consensus mechanism. And once again, massive thanks to Kevin for giving us the Kevin boards. And once again, a massive thanks also to Dr. Niraj for being here. And if I can, her first time on a space like this as well. So massive thanks. I know it's always hard to jump up for the first time as well. So absolutely crushed it and gave us a really good overview of all the, what the back end looks like, which for us in the front end, not seeing any of that. Like I said, we're at the party, but we don't understand all the work that went into getting the party started. So we're here.
And next week, we'll have another AMA on experts and node sales. We just dedicate 2 hours to that. And the L1X app version 2 is updated. And the L1X app version 1 that you see, l1xapp.com, is going to be updated with the version 2 features. So space cards, updated portfolio, experts, node sales, the updated balancer pool. Each and everything will be in the version 2 with the updated navigation. With the wizard, ticketing system has been created. So now you don't have to go to Discord and create tickets. You can go to your account section and write a ticket, and we'll get that and we'll solve it as well. And we are also thinking about introducing a live support feature where one of us will come on live and help you do it if there is a lot of problems. So the version 2 is jam-packed with a lot of features, and I can't wait until this is released to the people next week.
There you go, the sneaky alpha, the dates, all sorts of stuff flying out. If we drag this space a little more, imagine the amount of things that we could get to. No, that's probably enough. No, once again, huge thanks to everybody. A huge thanks, obviously, to the community and everybody that tunes in. On it at the moment, a 2 per week basis to our updates and our lives. It's been such a good cadence, I think, and so good for everybody to see how everything's working. We're really charging into, obviously, the proper mainnet launch, TGE, etc. So once again, huge thanks for everybody for being here. We'll close this out and we'll see you all on the very next one. Thanks for coming, everyone.
Thanks, guys.
Thank you.